1, we're working on the next section, which is more functions. And we're going to be talking about the graphs of functions and where they're increasing and decreasing. So let's look at this one. And this one says, where is this increasing and decreasing? And so increasing means that the function is going up, right, from left to right. And so this function is increasing up until this point, right? And so you do it with respect to the x-axis. And so this arrow denotes that this function is going all the way to the left. And so this is going to be increasing negative infinity up until 0. At 0, it stops going up. So it's increasing from negative infinity to 0 because, and again, it's the x value. Right? So for all these values, as you go across them, the function is moving up until there, negative infinity to 0. Parentheses around both of them. It's decreasing starting from after this point here forever. It will just decrease forever. So that is 0 to infinity. I didn't answer. Oh. Where's the function constant? Constant means that it's flat. This function is not flat anywhere. So there is no interval in which the function is constant. A relative maximum or minimum is just basically a hump or a place where you are the largest in that area. And so a relative maximum is a place where you're at a peak on the graph. And here there is a relative maximum at negative 3. This is a peak, and this in some small area is the largest value. And so there's a relative maximum at negative 3 because there's a peak there. What is the relative maximum? That means you want the actual value, so it's at negative 3, but the value is 4. Relative minimums, you could tell that they're here. It looks like there's one at negative 4 and negative 2. Those are like little valleys. So you're looking for the valleys, negative 4 and negative 2. I'll separate them with a comma, negative 4, comma, negative 2. What are those values? Well, they both touch the x-axis. That means that the y value is 0. I should only need to put 0 once, and that's true. That's good there. This one's a doozy, so we need to know the domain first of this one. So the domain is how far you go from left to right. This function definitely looks like it ends at 7, and it looks like it just continues going all the way to the left. So we're going to say minus infinity to 7. And the other thing to notice is that we should be including, I'm sorry, that's a 5. We should be including the 5 because it's colored in. So negative infinity to 5. Is the lowest value to the highest value. This looks like the highest value here, the highest y value, that's 3. But what's the lowest y value? Well, it doesn't look like this is the lowest. It looks like that's just going to keep going down forever. We denote that by minus infinity. That's the lowest y value. And then the highest y value, again, looks like it's 3, and we include the 3. The zeros are f. zeros of f are negative 1 and some other value. Well, the zeros are where you cross the x-axis, and so they gave you negative 1. The other place where this graph hits the x-axis is 5. What is the value at 4.5? We want to know at 4.5. So there's 4, that's 5. 4.5 looks like it's 1. We're going to guess 1. Let's see if that's right. The interval in which f is increasing, where is it going up? Again, looks like it's from minus. We said this the last few problems. Minus infinity up until that number 2. It looks like it's going up. Minus infinity to 2. Do not include the 2, so no brackets there. Decreasing from, it's going down like this, but that's over the interval 2 to 5. So you can think about it like a time interval. This is going down from 2 to 5 seconds. Again, not including the 2 or the 5, so don't use brackets there. Which interval or union of intervals represents the values for which f of x is less than or equal to 0? So we're trying to find out when is the graph under the x-axis. It looks like up until this point, including this point, and then you also need this. So less than or equal to 0, you need minus infinity up until negative 1, and then it says less than or equal to 0, and there's one other place where this thing is less than or equal to 0, and that is right there. 5 is where you're equal to 0, so you have to make sure you include that one. So this is kind of tricky. It's minus infinity to negative 1, including the negative 1, so it looks like this. Negative infinity to negative 1, and then that very funky 5. The function has no smallest value over any open interval, so there's no relative minimum. The relative maximum, where's the relative maximum? The function is where f of x is equal to, looks like it's 3. The relative maximum, the highest peak, that's the value 3. F of x is 3. What is the value of x when f of x is 3? It looks like the value is 2. F of 3, is it positive or negative? Well, f of 3 is above the x-axis. Means it's positive. And that's it. All right, we're going to do some piecewise functions. And so here a rule has been given to us, and we just have to follow the rule. And here's the rule. F says that, okay, I'm going to take any x you want. If you give me a negative x, then I'm going to give you a number back. And the way I'm going to give you that number back is I'm going to multiply that number by 5 and add 3. If you give me a number that's greater than or equal to 0, then I'm just going to add 5 to it. So f of negative 1, well, negative 1 is less than 0. So f of negative 1 is equal to 5 times negative 1 plus 3, which is negative 5 plus 3, which is negative 2. Because negative 1 fit into the first condition, you use that rule for that condition. Negative 2. F of 0. Well, f of 0, well, again, 0 is greater than or equal to 0. It's actually equal to 0, so I'm going to use this condition. It's 0 plus 5, which is 5. f of 4. Well, 4 is greater than or equal to 0. And therefore, I'm going to use the second rule. In this case, it's 4 plus 5, which is 9. And finally, I think there's another one. So g of 0, here's the function. If x is greater than or equal to negative 5, add 5 to it. If it's less than negative 5, 5 to it, and then change the sign. 0 is greater than or equal to negative 5, so I'm going to add 5 to 0, which gives me 5. Negative 6 is less than negative 5, so I'm going to take negative 6 plus 5 is negative 1, and then I'm going to change the sign to a positive 1. And then 1 is greater than or equal to negative 5, so I'm going to use this rule. 1 plus 5 is 6. I hope it helps, and I'll see you in class soon.